Okay, in this video we're going to look at the solutions to your first test, which is sketching parabolas using transformations. Just make sure you've got the right test. So looking at the heading up the top. This test only goes for 30 minutes. You're allowed your calculator, but no notes. So make sure you can understand how to do things because some questions you'll be able to do on your calculator, but others you will not be able to do. Okay. So starting off with 5 multiple choice questions. So the basic parabola y equals x squared is translated 3 units up the y-axis and 4 units to the left along the x-axis. So if you remember your equation in turning point form, which is y equals, I haven't put the a on there because it hasn't been dilated, so we'll just leave the a off. So remember the h refers to going left or right, and the K, oops, you're not going to see that, is up or down. Okay, so remember the turning point rule. Okay, I'm just going to clear that so we can actually see. Now, if we're going 3 units up the y-axis, that means K is equal to 3, positive 3. And if we're moving to the left along the x-axis, it means your value of h is negative 4. So basically we're going to be left with y equals x minus negative 4 squared plus 3. And remember the two minuses become a positive. So your answer for that one is C. All right, question 2. Which of these parabolas is symmetrical about the line y equals x squared? So you could either graph this or know that when it's in turning point form, and I'm going to write it again, that your axis of symmetry is x equals h. So if we're symmetrical along the line x equals negative 2, that means h has to be negative 2. So we need an equation where we have x minus negative 2 squared plus k, doesn't matter what k is. So we need to have something with x plus 2 in it, and you can see C is the only one with x plus 2. Alternatively, you could graph it to see where the axis of symmetry is. So if you graphed it, let me just quickly, I'll graph it here, but you can graph it on your calculator. X equals negative 2 is this line, okay? X equals negative 2. And basically you want a parabola that is cut with that line. So that's what it means by symmetrical. Okay, let's clear that actually. All right, let's go to question 3. Which one of these parabolas has 2 x-intercepts? So this one here you can also graph on your calculator, but you do need to know what each one is doing. So let's just look at them first of all. So the first one here, remember the value of k tells you what is happening. Whoops. I'll just make sure I circle that negative 2. This one has a 0. There we go, minus 1. And this negative sign we also need to take into account. So for this, actually I might draw. So we have, actually I'm going to clear that. We have either a positive or a negative parabola. And here are our sets of axes. So for the first one, we have a positive parabola that's shifted up 2. So it looks like that. So it has no x-intercepts. The next one, we have a positive parabola that's shifted down 2. So there we go. You can see it's crossed the x-axis twice. That's why that one is correct. The next one is a negative parabola, so upside down, and it actually hits, well, it's probably not there. It's more on that side. But it hits the, oh, actually, yeah, sorry, hits the x-axis just once. And then the last one, we have a negative parabola that's moved down 1. So it's actually not even crossing the y-axis. So you need to understand just by looking at these how your positive or your negative parabolas look compared to the x-axis. Okay, let's move on to the next one. Question 4 In the equation y equals ax minus h plus k, what will the h be doing? So this is the h here. It moves it left or right, so hopefully you remember that. The parabola with the equation y equals negative x minus 1 squared plus 7 has, so your turning point, when we have it in turning point form, and again I haven't written the a because our turning point is just at hk. So here our value of h is 1 and our value of k is 7. So it has a turning point at 1, 7. And this negative means it's an upside down parabola. So your turning point has to be a maximum. All right, let's keep scrolling. All right, so for this one here, we have to state the y-intercept, the x-intercept, and the turning point. So you can graph this on your calculator if you want to graph from your calculator, or you can see your turning point is at 3, negative 4. So I put that dot down first. Your x-intercepts are when y equals 0. So you can solve that to get 1 and 5. Okay, so you can either do that on your calculator or you can do that by hand. And then when you let x equal 0, we get the y-intercept, which is 5. So I've put all that information here because we had to put that in. And then when you're drawing your parabola, just try to join the dots as best as you can. And I could clearly see what the x-intercept and the y-intercept is, but you need to state that on the graph what the turning point is. All right, moving on to the next one, pretty much the same thing. Okay, so getting the turning point first. Noticing that this negative means it's a negative parabola. Finding your x-intercepts by letting y equal 0 and solving, and then getting your y-intercept by letting x equal 0. So there's your features over here and your graph. Alternatively, you can easily just graph it on your calculator and get all those features from your calculator. All right, question 2. The parabola with the equation y equals x squared has been shifted along the x-axis 2 units. So that means down, means k is negative 2, and to the right along the y-axis, so h is equal to 1. So there's our equation. When you're graphing this, basically always think of your origin, which is this point here. So that value has gone across 1, so you can see my little arrow there, and down 2, and there's your new point. And you can do that with any point. So I've actually chosen this point here because it crosses, that's negative 2, 4. So again, across 1, down 2, just to help you draw it. Basically, and this point here is 2, 4, so going across and down 2 to get your new point. You don't have to draw all 3 of them, so I'll just clear it so you can see, but it will help you draw your graph. So if you're good at drawing, that's fine, but you kind of have to have the same shape because the shape is the same. We haven't changed the dilation factor, just how it's moved. All right, scroll to the next one. Okay, so this is probably the hardest question in the test, and I won't write anything, I'll just talk to what we do. So the first equation, actually I might decide I will write. So this part here is our general equation. Okay, so it's just like when you did linear, you do y equals mx plus c, but this is our general form of a parabola. And you can do it in turning point form or expanded form or factorized form, it doesn't matter. But this question lends itself well to the turning point form. Okay, so we have a turning point of -1, -3, so you can see how I've substituted those values in there for h and k. And now it passes through the point 1, 5. So what I've done, I've just tidied it up here. And then I substitute in 1, 5. So y is 5, x is 1. Okay, and then basically I'm just solving for a. So a equals 2. When I've got a equals 2, I now have enough information to substitute it back into this equation here, or sorry, probably this one here. And this is what I am left with, the equation. So something that's a little bit more advanced, but what you need to know for next year. All right, I hope you understand that. And if you need any help, please make sure you ask me in class. Bye-bye.